Hello everyone, this is Sukesh Kulkarni and you are watching Cosmic Science. In my previous video, we have talked about black body radiation curve and how it failed to explain the very method of black body radiation. And in this video, we'll be learning about optical spectra and photoelectric effect. How classical physics or classical theory failed to explain optical spectra and photoelectric effect. We'll see in this video. Please stay tuned. Optical spectra. What, uh, what is optical spectra? Optical means which is related to light. Spectra in the sense the emission of light or emission of photons by transition of electrons that we obtain on a film. Where we record different types of spectral lines, so that is called spectra. So, optical spectra means the the light emitted by transition of electrons uh, on a film, which is recorded. Those are called optical spectra. So, each chemical, it may be any chemical, it emits an emissions. It shows a characteristic of emission spectra, which is in discrete lines. So suppose had suppose helium, it it emits spectral lines. This is optical spectra, and helium emits a certain optical spectra. So they are in discrete lines and they are separated by a certain distance. So they are not attached to one another. Each line has a certain intensity. Each line has its own frequency related to it. So uh, uh, later on, a scientist called J.J. Balmer, he observed that when a simple spectrum of hydrogen atom, he saw that he arranged the spectrum of those hydrogen atom transition of electron uh, spectral lines, and he arranged them in the series, and uh, he gave an empirical formula which obeys the how series are formed. This is the expression given by J.J. Balmer for the wavelength of the optical spectra that is obtained, and R is a Redberg constant, and these are the um, spectral line numbers. So he also obtained many other spectral series, and he gave they obeyed a particular spectral obeyed a spectral line formula, empirical formula, that is 1 upon lambda r 1 upon where m is equal to 2, 3, 4, and so on. And n is equal to m plus 2, m plus 3, and so on. So m is equal to 2, 3, and 4, and n is equal to m plus 2, m plus 3, m plus 4, so and so on. So this was given by J.J. Balmer, but there was a regularity found in these spectral lines, uh, uh, which indicated that there is a general mechanism how the photons are emitted, which was failed to explain by classical theory. Uh, Classical theory couldn't explain it. How photons are emitted, and what is the reason behind uh, general method behind emission of photon of a uh, particular spectrum. It couldn't explain it. Uh, so it so classical theory failed at this point. Let's see about photoelectric effect, how it failed. Uh, what is photoelectric effect? When a light falls on the metal surface, the electrons are released, and those electrons are called photoelectrons, and the phenomenon is called photoelectric effect. So, in photoelectric effect, there were some investigations and some researches were done, and they found out that some conclusions. Those are energy distribution of a photoelectron does not depend on incident light, intensity of incident light, and the uh, and also, it states that maximum kinetic energy of photoelectrons is directly proportional to the frequency of incident radiation or light. It also explains that the conclusions also explain that energy for a given frequency, uh, the photoelectrons are a number of photoelectrons are directly proportional to the frequency of incident radiation. So, photoelectrons are not emitted when the frequency of incident light, radiation or light is below a certain threshold frequency. So, suppose there is a incident radiation which is below the threshold frequency, no photoelectrons are or electrons are released. So, they do not absorb the radiation, and the photoelectrons are not released. So this was these were the conclusions of photoelectric effect, but it couldn't explain uh, how exactly the phenomenon occurred, how photoelectrons absorb the radiation, and how they re-emit the radiation, how um, uh, the photocurrent is generated. It couldn't explain, the classical theory couldn't explain these all the things, so it failed in explaining all these phenomenons. So these were the two failures of classical theory, where, in which quantum mechanics has to interfere and explain those concepts in further videos. I'll be explaining all those things. So this was about optical spectra and photoelectric effect. We'll see uh, some more topics related to classical theory, uh, which failed to explain certain phenomena. So if you like this video, please do share, like and subscribe. And if you have any doubts, please comment down below. Uh, so so this is for all. See you in the next video. Thank you.